There is a question. Let us try to answer that. RLC configuration by RRC means RRC reconfigures RLC and send it to configuration to UE. Hmm. Actually, RRC is capable of configuring any protocol layer that is present in the below, including RLC. But RRC messages will have to travel through RLC itself. Now, the kind of question that we'll get, we discussed that earlier. Hen is first, egg is first problem. RRC messages need to go through RLC, but to configure RLC, we require RRC. Now, which one comes first? Do we configure RLC first, or do we send the RRC message through the RLC first? Obviously, none. Both the things are not possible with one another, without the other. So that is where, to break the ties, they have built in this concept called as a default configuration. That is what we are seeing right now. So at the starting, RRC won't configure any RLC at the starting. At the starting, configurations are by default, these configuration parameters are used, the ones that you are seeing right now. But with this configuration, mobile would be able to receive the messages that are required to be received from RRC. So RRC messages can travel through this RLC default configuration mechanism. And then we get the dedicated configuration. The moment you get the dedicated configuration, now you will start using that configuration instead of using the default configuration for RLC. Is that clear, Pavan? Okay. Now take a look at the default configurations. For example, mobile need to use CCCH when it is in idle mode, when it did not have uh, any of the configuration existing. So it is CCCH configuration, stands for Common Control Channel. Now, when does mobile use this CCCH? Let us go back. So if you take a look at this, SRB0, while there is no SRB1, SRB2 present, first time when the mobile is like trying to communicate with G node B, that time it is using this SRB0 on CCCH. Now, at this particular stage, what exactly should be the mode in which RLC should work? What are the MAC level related details? If at all MAC is actually doing some kind of a logical channel prioritization, etc., what are the logical channel related information? So this is what we call as default configuration. So if we go back, SDAP not used because SDAP is for user plane, not for signaling. CCCH is used for signaling or RRC. PDCP not used because RLC is operating in TM mode. So this is the default configuration. Both mobile knows this, G node B knows this, that if they are operating on CCCH logical channel, this is how they have to work. And logical channel configuration, priority is one, which is the highest priority. Anyway, when you are using CCCH, you won't be using any other channel also. DCCH, DTCH won't be there when you are having CCCH. Reason is, CCCH is before RRC connection, DCCH, DTCH are after RRC connection. You cannot have both the things at the same time. Obviously, when you are sending CCCH, no other channel would come for competition. So priority is highest, prioritized bitrate is also infinity. Priority is bitrate infinity means that is also highest. Whatever the data that is there, you have to take the entire data. That is the meaning of prioritized bitrate set to infinity. Bucket size duration is 1000 milliseconds, which is equal to 1 second. That means if a message arrives at CCCH logical channel, RLC TM mode entity, in how much time the data must be sent out without a failure. Just you have 1000 milliseconds for that, which is 1 second. Within 1 second, MAC layer must pull the data and send it out. How much amount of data that is pending, it doesn't matter. The size can be anything, but it must be pulled out and sent within this 1000 millisecond time frame. Now, logical channel group is zero. If at all, for any reason, if you have to report the buffer status, so you have to consider that logical channel CCCH belongs to group number zero. You have to count its size under group zero. Similarly, BCCH BCH configuration. RLC works in TM. There is no logical channel configuration also applicable for BCCH PCCH, because typically these things would be sent on common resources, and our dedicated physical channels would be there to send the BCCH, for example, like PBCH, etc. You won't be like providing any kind of a priority related mechanisms, not needed. When you are operating with BCCH or PCCH logical channels. Default MAC cell group configuration. What is the MAC level configuration that you have to use? Uh, Buffer status reporting. Periodic buffer status reporting is SF10. Every tens of frames once you have to send the buffer status. And if you are not provided with the resources even after sending the buffer status, you are allowed to resend the buffer status report once again after SF80, after 80 subframes. Like that, some timer related values are configured. Similarly, power headroom report related configuration. How often you have to send the power headroom related report? You send every tens of frames. After sending the PHR once, you have to prohibit sending the PHR for another tens of frames. And PHR power factor. Like, for example, you not only have to report the PHRs at regular intervals, but sometimes you have to report the PHR even when there is a sudden signal strength loss, at least by 1 dB power, for example. If you lose 1 dB power, you have to send the PHR, 1 dB path loss, 1 dB power loss suddenly, which is considered as kind of drastic power loss. If you if without this power loss, you will be regularly reporting PHR every this much amount of time. But if power loss happens, typically you will be immediately reporting it. Hey, there is a huge amount of path loss for me. I don't know, maybe I'm entering into an area where there is some black spots, like where the signal strength is not available, kind of stuff. Okay. Not only for the common channels, even for the SRBs, SRB1, SRB2, SRB3, which are actually configured after RRC connection is established or during the RRC connection establishment, even for them, there is default configurations available. And these configuration details are known to the mobile. Now, at the time when your mobile equipment is requesting, network will try to configure SRB1, SRB2, and SRB3 during the RRC connection or little later than that. Your network is allowed to configure you these SRBs. But if network did not provide any SRB1 configuration during the RRC connection setup, then mobile will have to apply this configuration. But if network provided SRB1 configuration, then whatever the details that are provided will override these values, the default configuration values. For example, when it comes to CCCH, BCCH, etc., there is no overwriting. These are like kind of fixed. Any mobile equipment in the 5G world will have to use this CCCH, BCCH, PCCH configuration, exactly this configuration only. There is no possibility for changes. It's a fixed configuration. But when it comes to SRB1, 2, and 3, there is default configuration existing. But now it is the decision of G node B whether to change any of these parameters and modify it with its own values or keep the values intact. Um, GNodeB decides that. If GNodeB decided to change this, definitely GNodeB will provide SRB1 configuration details when it is accepting the radio connection or RRC connection. And in that, it will clearly indicate which all the parameters it is changing. Obviously, whatever the changed values are there, you have to override those values into these positions. For example, if you take SRB1, SRB2, or SRB3, for for all these three things, except these two lines that you see, logical channel identity and logical channel priority, other than these two things, rest of the details are the same, as you can see. For example, PDCP, T reordering is infinity at PDCP level. RLC is going to operate in AM mode for all these three SRBs, SRB 1, 2, or 3. And uplink AMRLC related configuration um, from the mobile from the mobile side. What is the SN field length? 12 bits. Actually, we have two different sizes, SN field length in AM. So we are choosing it to be 12 bit, the default value. If you did not get the status report, you will be resending the poll request after 45 milliseconds. T poll retransmit. Poll PDU is infinity, poll byte is infinity. So there is no parameter that is set. That means when you are requesting for the status report, mobile equipment is given a choice to pick up when to request for the status report. Network is not setting any value. That is the meaning of it is set to infinity. Maximum retransmission threshold. So in AM mode, when you get a negative acknowledgement, you are allowed to retransmit. So how many times you are allowed to retransmit? Maximum 8 times. Similarly, in case of downlink, SN field length, same. When you perform the reassembly, when you are receiving the downlink messages in the AM mode, uh, every 35 milliseconds once you perform a reassembly operation. That's the default reassembly timer. Um, if requested from the GNodeB for the downlink traffic, you have to send a status report. But how often you will be sending the status report? Um, it will be dependent on the request from the GNodeB. But after you sending a status report, do you have to prohibit sending the status report once again? Actually, because it is set to 0 ms0 millisecond 0, that means you are allowed to send the status report even immediately if requested. So there is no provision is in place here. But if network thinks that it need to change this value, it can suggest a new configuration during the connection establishment request. Okay, logical channel identity for SRB 1, 2, 3 are fixed 1, 2, 3 logical channel numbers. These logical channel numbers cannot be reallocated for any other purposes other than SRBs 1, 2, 3 respectively. For example, if a DRB wanted logical channel number, you remember logical channel numbers we use while constructing the MAC transport block. By pulling the data from the higher layers, we packaging it, keeping it together, we use logical channel identity. So that time we have to, include these details in the MAC transport block header formation. For that reason, we need this logical channel identity. So what is the logical channel identity associated with SRB 1, 2, 3? What is their priorities? Logical channel 1 and 3 are prioritized. So their priority is 1 compared to logical channel number 2 or SRB2, which is having priority 3. So that means if SRB1 and SRB2 on both the entities, we are sending a protocol message uh, to RLC. The RLC1 received one protocol message, RLC2 received one protocol message into their buffer. Both of them reported to MAC layer that there is some amount of data in waiting in our buffer. But if MAC got the resources to be able to send only one message out of the two, so which message will be preferred? Uh, SRB1 message will be preferred or SRB2 message will be preferred while forming the transport block? Definitely it is SRB1 message that would be preferred. But now you can ask, hey, what if SRB1 and SRB3 both wanted to send the message? Which one will be preferred? Actually, both will be sent. One more important point is, if a mobile equipment is connected to only one cell, mobile can have only two SRBs, SRB1 and SRB2. SRB3 is required in dual carrier cases, where mobile equipment is connected to at least two cells. It is using something called as a secondary cell as well, along with the primary cell, to increase the data rates. Now, this SRB3 typically is used for secondary cell communication. Mobile, if mobile want to communicate with the primary cell, it will use the SRB1. Mobile to communicate with the secondary cell, it will use the SRB3. But because we did not study much of the secondary cell related configurations, we'll ignore from here onwards, we'll ignore SRB3 related discussion. But because it is present here, I have explained here. So without the secondary cell, how many SRBs mobile would have is only two, SRB1 and SRB2. And for these SRBs, prioritized bitrate is infinity, and bucket size duration is not even identified. Logical channel group they belong to is zero. If while reporting the BSR buffer status report, so you have to consider the sizes that these that are waiting in the SRB1, SRB2 buffers under logical channel group buffer size. We learned about these groups. During the configuration, we'll have these groups and things works like that. Okay. So there are some default timers and constants as well. Normally, timers would be used for different operations. Uh, for example, there is a timer called as T310, which is set to 1000 milliseconds. Now, this timer is used in one of the RRC procedures. Which RRC procedure we'll see later is used in some RRC procedure. So the idea of this timer 1000 milliseconds is, during that procedure, you want, for example, you would like that procedure to be get completed within 1000 milliseconds. If not completed, you will consider that procedure as a failure, as a permanent failure, because it did not happen within this particular timer set. So T310 is one timer. Anything that starts with a T is a timer. 310 is a code for it. T311 is another timer, which is set to 30,000 milliseconds, which is equal to 30 seconds. But both these timers would be used in two different situations, two different scenarios. Similarly, there are constants that the elements that start with the letter N are considered as constants. So N310 value, default value is N1. N311, default value is N1. Again, these constants also will be used in some RRC procedures. Of course, is it possible for the Gnode B to change these values? Yes, because these are default. If you want, you can modify them. Gnode B decides whether to modify or not. If Gnode B is not providing a new set of values, these values are applicable. That's the point of default always. Great. So when mobile is dealing with all these BCH, PCH, BCCH, PCCH, CCCH, etc., it will be using default configuration. But SRB1, SRB2 also can have default configuration. But I'm telling you, during radio connection, network either can tell the mobile to continue using the default configuration or change the values according to its own thinking process. Both mechanisms are allowed. If network did not provide you additional details or changed details, default values are applicable. So even these DCCH, etc., need to have this, need to work with this default configuration. These parameters, every protocol layer, how AMRLC should work, how PDCP should work, what is the logical channel identity that is considered by MAC layer while constructing the transport blocks, what is their priorities, when we have to compare which logical channel data we have to send first. All right. So from there we get on to the next topic. The natural topic is UE states. So we have been telling, starting from this training, mobile equipment would be in something called as idle state and connected state. So obviously we would wanted to go through these, what is the meaning of these states, how many states are there, what kind of, what is the difference between the states. Can anyone tell me what is the meaning of a state? What is the meaning of a state? Please participate, guys. What's the meaning of a state? Situation. Okay. State means condition of an UE. Okay. Or condition. Okay. State is just a set of properties. Okay. Almost all the answers are correct. Okay. So what is a state from a protocol point of view? It defines a state is kind of tells you what kind of information or parameters that are available for the mobile. And with by using those parameters and information, what activities can be performed by the UE. Typically, this logic is the same when you study these protocol states associated with any protocols. Doesn't matter what those protocols are. Even if it, because we are right now studying RRC, so this is true even in RRC as well. For example, if mobile can be in three states: RRC idle, RRC inactive, RRC connected. The kind of parameters are the information that the mobile know in RRC idle, RRC inactive, and RRC connected would definitely differ. The same information won't be available for the mobile equipment in all the three states. Different types of information will be available depending on what kind of activities UE is supposed to perform in that particular state. So the major details that would be different is what details you know. With the help of those details, what you can do. That is what is a state. For example, let us take your Gmail. In your Gmail case, we have two situations. Gmail logged out state, Gmail logged in state. In Gmail logged in state, you can see your Gmail. You can write a mail to someone, send it. In any mails, if you have attachments, you can download them, etc., etc., etc. Lot of activities you can perform. But when you are in a logged out state in Gmail, you can do all that. Logged out state, if you wanted to send a mail, it will not accept, even though you know it's already logged out, and but still the page is appearing. If you try to, for example, if you try to uh, write a mail and use click on the send button, it won't work out because you already logged out, maybe in another window. So it will take you out. This mail transmission will fail. It will take you out of the Gmail. It says that you have to log in once again in order to perform this act, in order to perform this activity. So the state is a generic thing. So from RRC point of view, there are three states: idle, inactive, connected. So what are the different things that the mobile can do in these states, and what information it will contain is what this particular slide tells us. What does the UE do in RRC idle state? UE may be configured with a DRX, a discontinuous reception from the upper layers, to listen to a channel called as PDCCH to get to know the incoming calls or paging messages. Even if the mobile is in RRC idle state, mobile would be listening to PDCCH once in a while. The uh, the channel which is going to tell you the scheduling details, DCA information. Why do you need to listen to PDCCH when you are in idle? You may be getting incoming call notification from the network, which we call as paging. That paging notifications would arrive on PRNTA reservation with the DCI on like a paging channel, or your paging information would come. But for that purpose, you need to keep listening to PDCCH. But if you continuously listen to PDCCH, your battery will be drained out. So then a DRX must be configured. If you remember, we have studied this DRX mechanism in the MAC layer. But MAC layer DRX works when the mobile is in connected state, not in idle state. When the mobile is in connected state, but not doing any transmission reception, network will find out your inactivity and will command you to go into DRX state by sending a MAC control element called as a DRX command or long DRX command. We have studied that. But that is when Mac can send that control element when it is in connected state. But right now, mobile is in idle state. In idle, mobile is not connected to G node V. It can do much of the operation. So a DRX would be configured by the higher layers. So mostly it is done with your system information. This DRX will be configured. Based on whatever those DRX settings are, based on that, you would be listening to PDCCH once in a while to find out your incoming call related information. Next, UE controlled mobility. Mobile can perform mobility related actions on its own. UE controlled mobility. What is the meaning of that? If mobile wanted to move from one cell to the other cell, it will choose that on its own decisions, whether to continue in the present cell or to go into the adjacent cell. Mobile would keep measuring the signal strength of the present cell. Any moment mobile found out that signal strength of the present cell is becoming pretty bad, mobile actually may find out, try to find any other cells that are nearby, and it can select some other cell and starts operational with that particular cell, and it continues in this RRC idle state but in a different cell. It can do it. It will have complete freedom on that when you are in idle mode, not doing anything. Right now all our mobile phones are in idle mode as we are not using them, typically speaking. So UE controlled mobility would be there in place based on the network configuration. What is this meaning of network configuration? Network will kind of give the hints to mobile about this particular mobility part. What kind of hints that network will have to provide? For example, this is a cell where mobile equipment is present under in some position. Mobile, when it is measuring the signal strength, it will get some signal strength value. But how does the mobile know whether the signal strength you are getting is good enough for this particular cell or bad? How do we know that? How do we know that measured value is good to continue in this cell or bad and you cannot continue in this cell? Oh, Why mobile don't know? You can tell that, hey, mobile know which number is a good number, which one is number is a bad number, isn't it? But that's not the concept. For example, if the cell size is only this much, whatever the signal strength mobile is getting from the cell is kind of considered under the bad category because it's outside the cell range. You should not be using the services of this small cell that is present here. If it is a big cell, definitely whatever the value that the mobile is getting is within the cell range. So that means, for example, if mobile equipment is getting a signal strength of minus 70 dBm, decibel milliwatt, what is it? I will explain in some time now. But this minus 70 dBm is good or bad, mobile don't know. That will be dependent on the cell size. For small cells, very, very small cells, like micro cells or uh, 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 we call it as umbrella cells. Very small, small cells can be created, which operates in 20, 30 meters range only, for example. For such cells, minus 70 dBm may not be a good signal strength. But if you have a cell in a rural area, like in a village, even in a 10-kilometer range, also you might not have a cell. So very big cells would be configured in there. Oh, okay, now their minus 70 dBm is considered as a superb signal strength. So this changes from situation to situation, whether we are operating on FR1, FR2, what is the size of the cell, and various other details that operator configures in the network. So definitely network need to provide knowledge to the mobile equipment about which cell is better for its operations, or when a cell must be considered for its selection, when a cell should be considered as a positive thing or should it be considered as a negative thing. So complete information will be provided by the network. Obviously, how the network know it, how the GNODB knows these details to provide it to the mobile. Actually, this information will be provided as part of system information details, SIBs. But first of all, how GNODB knows that to provide it? What is the size of the cell, etc., etc. Operators will configure these cell related details, and operators are the ones who will configure this information into your GNODB's software. What is the cell size and what value is good, should be considered as good for the cell, what value should be considered as bad for the cell, etc. Because when operators are bringing up the network, they know what they wanted to do in the geographical location. So on the basis of what's happening in the network, they'll decide that, like what kind of a cell they are bringing up. On the basis of it, they will decide all these parameters, and they'll configure these details into GNODB software. GNODB software will stuff all those messages into system information. The moment mobile equipment comes into the cell, starts synchronizing with the cell and reading the system information, mobile will get all these parameters that are related to UE controlled mobility mechanism, like how to evaluate these cells, what are the cell evaluating criteria. So mobile is given permission to select whichever cell it wants to use on its own. It can independently make a decision to leave one cell and go into the next other cell, especially when it is traveling. It never need to communicate with the network about it when it is in idle state. Even when you move from one cell to the other cell, you don't need to tell the network that you are moving into the new cell. Not required, because you are not using any service. So network is kind of not interested in finding out where you are exactly located in which cell. Of course, if required, network will search for you by sending the paging messages in one set of cells, in a big range of cells. It will distribute the paging message to ask you to respond for an incoming call. Network can do that. But network don't want to monitor each and every step that you are taking, each and every mobility action that you are performing when you are in idle mode. So mobile would be monitoring this paging channel with two different RNTIs, 5G STMC and PRNTI. It will be monitoring. If it is PRNTI, that is your radio network is trying to send something to you in the form of something called a short messages. What is it? I'll explain in some time. But if your core network identity is used for paging, that means you are getting something incoming. That means within radio related reasons, if network is searching for you, it will use PRNTI, send the information over your PRNTI. But if network is searching for you for reporting you that there is an incoming call, IMS call or voice call or IP packet data that is incoming to tell you that to make you move out of the idle state into connected state, in such cases, network will be searching for you by using this, 5G STMC. But even when you got a paging message or not on your 5G STMC, even for that, mobile equipment would be listening to paging channel with PRNTA itself, PRNTA as the reference in the DCI, downlink control information. So downlink control information CRC would be scrambled with this PRNTA. This PRNTA is a fixed number 65,534, which is fixed in entire 5G environment. Every 5G mobile phone knows that PRNTA is 65,535. So if they are listening to paging channel or if they are listening to PDCCH, so they will try to see which CRC is scrambled, which DCI part CRC is scrambled with PRNTA. That part they will download. But when they downloaded the DCI, downlink control information, which is scrambled with PRNTI, in the DCI they will look for whether a paging message is present with the STMC or a short message is present. If there is a short message present, radio network is trying to tell you something, but if a paging message is present, then definitely PDSCH resources will be reserved for you. You have to download the PDSCH information. In that, inside that, you have to see whether your STMC is present in it or not. So let me let me show you this DCI part. We have already seen DCIs. So the DCI we are seeing here is DCI format 10, where the CRC is scrambled with PRNTI instead of CRNTI. What details will be there when in the DCI when it is scrambled with PRNTI? First, it will indicate short message indicator, 2 bits. It is going to be set to, okay, sorry, I think this is a mistake. The description is not correct for that. That is wrong. Remove it. Uh, the short message indicator 2 bits will give you value. Four possible values are there: 00, 01, 10, and 11. Four possibilities we have. So those four possibilities are listed here. 00 means reserved. 01 means it is kind of telling you only scheduling information for paging is present in the DCI. 10 means only short message is present in this particular DCI. 11 means both scheduling information for paging is there, short message for with DCI is present. Both are present. So three valid values. Okay. Um, what is the difference here in these three valid mechanisms? Only short message is sent. It is radio network trying to tell something to you. It is radio network related paging. So when the value is set to 01 or when the value is set to 10 or 11, you will have this short message related information here, which is going to be 8 bits. In those 8 bits, First, if the first bit is set to 1, it indicates that, hey, whatever the system information that you already downloaded earlier, that has been modified. Please download the system information once again. Operator has made some changes in the system information that you have downloaded earlier. Now it is the time for you to download the fresh ones, fresh system information. So this is sent by radio network. It is radio network related interest. This is not telling you about incoming call. The short message is not telling you about that. It is telling you that please understand that I know that when you have synchronized with the cell, you have read this SSB block. From the SSB block, you have received the MIB remaining system informations. You have read one after the other. I know that, but there is a change in the system information. Now, if you don't download the new system information, you would be using the old parameters, old system information. That is kind of not good. You won't survive in this cell with the old configuration because the configuration has been changed. Similarly, if the bit 2 is set, it's kind of telling the mobile equipment that, hey, there is a ETWS or CMAS related system information got modified. These ETWS and CMAS will be present in SIP 6 and 7 and 8. So if these three SIPs are modified, what are they? I will explain later. But if these three SIPs are modified, second bit will be set to 1. Mobile equipment will need to download that ETWS or CMAS related system informations. But any other SIPs other than these three SIPs, system information blocks, 6, 7, 8 have been modified. First bit would be set to 1. It's like that. Depending on which system information blocks are getting modified, network is indicating. So network is sending a paging message to mobile equipment which is sleeping, idle mode, that, hey, I know that you are sleeping, sorry to wake you up, but please listen, there is some system information that has been modified. Please download the fresh one. After that, if you want to sleep, you can sleep. You are allowed to do that. Remaining things we will kind of ignore for time being. These are required for shared spectrum channel access, like which we have ignored, that is used normally in cases of um, non-standalone 5G. But you guys are learning the 5G only for standalone mechanism. So we'll ignore those two things. 5 to 8 bits are reserved for future. There are no use with them. So these 3 and 4 also we are kind of ignoring for time being. Okay. So if the first 2 bits are set, network is kind of telling you with these 8 bits that, hey, you have got a system information modified. Please download the fresh system information. But if the value is set to 0, 1 or 1, 1, in these cases, now these additional details also would be present where frequency domain resources will be available, time domain resources will be available, modulation and coding scheme and additional details like that will be available. With indirectly, network is telling you that, hey, there is some resource block reserved on PDSCH for PRNTI. Please download that resource block, which I am indicating here with this frequency domain resources and time domain resources. If you download that and you decode that message, once you decode it, and inside it, you have to look for something called as core network identity. Normally, whenever mobile equipment registers with the core network will throw you a number. He'll tell you that, hey, please take this number. I am allocating it to you. So whenever you register with the AMF will provide you a number. So you have to look in this decoded message whether your core network allocated number is available or not. If it is available, that means that you are getting a paging message for incoming call or incoming data. So network is kind of telling you that, hey, it is the time for you to come out of the idle mode, maybe come into the connected state, RRC connected state to download the incoming data that is arriving for one of your application. Till now you are in idle mode, that's fine, but now you cannot. So that's the point here. So here you would be downloading PDSCH. other than DCI. But if there is no indication related to normal paging, if the indication is only related to short message, that means it is only talking about system information changes. So mobile don't need to go into connected state. Only the thing mobile can do is simply download the fresh system information that is getting broadcasted in the cell. That's it. He may not require to go into connected state and talk to the network, because it's not about incoming call. It is just to tell you that system information is modified. So the DCI format 10 would tell the mobile equipment if only radio related paging is happening, or core network plus radio related paging is happening, or only either one of it is happening. When it is scrambled with PRNTA, which is a reserve number 65,534. SIRNTA is 65,535. This is 534. These are fixed numbers. So you would be monitoring that. And mobile would be performing neighboring cell measurements on its own. Of course, mobile would know how many cells are present in the neighboring areas where you are. For example, right now when I am sitting, there are like uh, if I am using, for example, Reliance Geo network, other than the cell that I am using, there could be maybe 5 6 different Reliance Geo cells itself in the vicinity in this particular area. 5 to 6 different cells. But why mobile would have selected the present cell is because its signal strength is higher than the others, at least during the starting situation. But you don't know, mobile don't know when the human moves. When the human started moving, after some time the situation changes. The present cell won't be the best cell. One of the adjacent cell or one of the neighboring cells will maybe become better. So it is the duty of mobile equipment to keep measuring the signal strength of the present cell as well as the adjacent cells. And whichever cell is giving him the better signal strength, it will have to select that cell. So in idle mode, mobile would be performing an important activity called as cell selection and reselection. Okay. First of all, what is the meaning of selection? Well, like selecting a new cell. That means you decided somehow the present cell signal strength is bad and you have decided to select a new cell. But what is reselection? You are reselecting the same cell. That means you measure the signal strength of the present cell, you measure the signal strength of the adjacent cells, but you concluded that present cell is still better than the adjacent cells. None of the adjacent cells are looking good for you. So you reselect it. You be there in the same cell, operating in the same cell. You don't need to leave that cell. Acquires the system information. uh, if required, mobile can request for the system information by sending something called as SI request. If, for example, if you are interested to read one specific system information, you can send a request to the network. Hey, can you please send me that system information? What is this SI request? In 5G, what they did is there are a lot of system informations available. They thought that if you start reserving the resources for sending each and every system information block, you require to reserve a lot of resources, which is kind of considered as waste of resources. Because system information is needed for every subscriber. Up to 4G, what happened is they kind of were reserving the resources permanently for system information blocks up to 4G. So any mobile that is coming up into the cell, even night 2 o'clock also, you can download the system information silently from that particular, identify those locations and those resources and download it. But in 5G, they have kind of come up with a new technology. They said that, hey, this kind of a continuous transmission of the system information is, of course, required for the mobiles, because you don't know which mobile will what time. They require system information to survive in that cell. So what old idea was it need to be retransmitted 24 by 7. And that is how they have done it in up to 4G. 24 by 7 they used to retransmit, continuously keep transmitting it every regular interval. So that any mobile that comes up into any new cell, any cell, they would be able to easily download it without having any trouble. But in 5G, the thought process changed. Why to waste the resources? Let us build a new concept where if mobile requires any system information, if a new mobile comes up and requires any system information, we'll ask the mobile equipment itself to request for it. Then we provide it. Only very, very important system information, we'll continuously transmit it to 24 by 7. Like, for example, MIB that is sent as part of your SSB block. SSB blocks would be transmitted on your radio frame continuously. In every radio frame, the SSB blocks will be there. And continuously throughout 24 by 7, SSB blocks would be there. So because MIB is important information, master information block, the details it will carry, so you have to send it continuously in every SSB block. So that details you can't escape. You can't ask the mobile equipment to request for it. You have to keep sending it. But other system informations, you can ask the mobile equipment to request for it. Hey, only if you request, I will reserve the resources for it and transmit it. Otherwise, what is the need? It's useless, right? So if I keep sending it, but nobody is reading that system information, you are kind of wasting the resources because nobody is reading it. So instead of using the resources for sending the data of some subscriber, important data, you are utilizing the information for system information, which nobody is reading. Actually, system information is very crucial information in a telecom network, in a telecom environment, in a telecom cell. Any mobile must read the system information to survive. All your telecom technical details are present in that system information. It's very much required. But how many times you have to read the system information? Typically, only once. Most of the time, system information won't be changing. It will be the same information that keeps getting repeated 24 by 7. For example, if operator did not modify their sale related configuration for 6 months, system information could be same without even a single parameter change. So that means any mobile that comes up into that cell for the next 6 months, whenever they read the system information, they will get the same details, same system information. Because they're not getting changed, not much, other than except one or two details. Maybe timing related details or your frame number related details, radio frame number related details might change. Other than that, most of the information will be repetitive. So mobile need to read the system information once. But because lot of mobiles will be there and mobiles will keep coming into the cells, going out of the cells, to accommodate everybody, you have to kind of broadcast this system information 24 by 7. That was the original idea. When the system information is built into the network, in 2G network, 3G network, 4G network, etc. That is what they have followed up to 4G. Continuously broadcast the system information 24 by 7 in some repeated time intervals. Even with there are no subscribers who are interested in it, but that they have changed. How this works out, we'll study. How this system information requesting mechanism will work out, we'll see. But this is only on the configuration basis. System information request works only on configuration basis. If network tells you, hey, this SI request is not configured, then definitely you will be receiving your system information continuously with a time gap or a time interval configuration. So that time you don't need to request for the system information. Already you will be provided details with where you have to look for the system information. And you look there and you download it and you decode the information, which will get you the required system information details. So it again decided by the operator on the cell which method to use, whether to distribute the system information 24 by 7 by reserving the resources at constant rate, or you have to ask the mobile equipment itself to request for the system information. Both are available in 5G. Up to 4G, we have only first one is available. 24 by 7, you keep distributing the system information by reserving some resources. Next, performs logging of available measurements together with location and time related loggings. Now, again, it is a new concept in 5G. Up to 4G, it was not there. Concept is even when the mobile equipment is in idle mode, network will ask the mobile equipment that, hey, you keep performing I know that you keep performing the measurements, but what I'm doing is I'm asking you to log those measurement results and please provide me those measurement results once you come up into the connected state. Once you come up into the connected state, I will allocate you, I will create your SRBs, etc. By using one of those SRBs like SRB2, you send me all the measurements that you have collected so far, that you have generated so far. You send me at least the highlights of that. I would like to know. So this is a new mechanism. So not only mobile would be measuring the things, but it will be maintaining a log of that and provide those details to the network when requested, when when go into connected state. So idle and inactive measurements are the same things basically. So these are location based measurements, location and time, and these are idle mode or inactive mode measurements. So different types of measurements are requested by the network to be uh, collected while it is in idle mode and provided once you move into connected state. Okay, next. First we study RRC connected state, even though inactive is in the middle. UE stores the AS context. AS represents access signaling, which is another name for RRC. It it maintains RRC context, RRC related parameters that are provided to you by network. During radio connection requesting, network will provide you a lot of details, configuration details. So those configuration details would be stored in the mobile. And mobile is capable of transferring the data either in the uplink direction or in the downlink direction. Unicast means one to one, its own data. It can transmit and receive. It is not the data that belongs to multiple subscribers. It is the data that belongs to one single subscriber. That's what we call as unicast. Of course, when the mobile is in connected state, there is a possibility for DRX at lower layers. Here, lower layer refers to MAC layer, which we have already studied. At the MAC layer, we have this concept of discontinuous reception to listen to PDCCH only once in a short while or a long while to save your battery power. This happens when you are even though when you are in connected state, but you are inactive. That means you are not doing much of the stuff, like you are not transmitting or receiving the data much. So that time you will be moved into the short DRX or long DRX states. That is possible. We'll ignore these 2 points because those aspects I'm not teaching you. Carrier aggregation or dual carrier mechanisms like secondary cell groups, etc. So we are studying the single cell configuration. So we'll ignore those. Sorry. Network controlled mobility. What is it? Mobile is allowed to move from cell to the cell, even in the RRC connected state. But you must be dependent on the network for that. If you wanted to move from the present cell to the adjacent cell, you have to beg the G node B. Hey, G node B, please. I am here right now, but my cell signal strength is not looking so good. Can you please move me to my adjacent cell, which is looking better for me? Please. Mobile need to beg the network. Why? How come mobile equipment is not asking the network's permission in idle mode? When it wanted to move to new cell, it decided to move on its own, which we call it as UE controlled in this particular case. But here we are saying it is network controlled. Why we are dependent on the network? Anyone? Why is that? Can anyone answer that? Why we are dependent on the network's decision here for moving? What's the difference between idle and connected? Anybody participate, guys? All right. In the connected state, mobile equipment is using the services. It is basically transporting the data in uplink and downlink directions. Now, in order to transport the uplink and downlink data, you require resources. So there is some continuously some resources that are getting configured for you in the present cell, in whichever cell that you are located. So by using that resources, you are sending the data in uplink or receiving the data in downlink. If mobile decides to move on its own to leave the cell and use the adjacent cell, now in the adjacent cell, you don't have any configuration existing in the adjacent cell. You are using the configuration that is provided to you by the present cell. If you decide to move on your own into adjacent cell, you have to request for this connection and you have to request for this configuration freshly to from the scratch because you decided to move on your own. But that's we don't want that. If mobile equipment will have to do this operation, it will have to request for a radio connection in the new cell. The ongoing service, whatever that is going on, that will be halted at least for some time. You will be missing that service because it takes time for the mobile equipment to sync with the adjacent cell and request for a radio connection and get it accepted. All of that will take time. Mean while the mobile is at it, your voice call, if you are, for example, if you are on a voice call, your voice call data would be stopped sending because you already left this cell. You started tuning into the cell. So you're losing your ongoing service. So that is why you are dependent on the network. So mobile will tell the network that, hey, present cell is not looking good, but the adjacent cell is looking good for me. So the idea is when you tell this to the network kind of communicate with the other network component if required. It will tell the other guy that, hey, one of my guy wanted to come into your network. If he comes there, he will be requiring this kind of a configuration. Can you please configure the details according to the present need of the subscriber? I'm demanding it. So this guy says, okay, I think I'm accepting this handover. I'm ready to accept the guy into my cell. So this is my configuration. It will provide the configuration details to the your GNodeB. Now GNodeB tells the mobile, hey mobile, earlier you told me that you are not, you are not feeling good in the present cell. You told me you wanted to move into the adjacent cell. See, I am really good guy. I have gone on and spoke to that other guy and got you all the details that are required, got you all the configuration that is required. Now only the thing you need to do is leave my cell and please immediately go into the adjacent cell where the configuration is ready for you already. Configuration is ready and the day is waiting for you. If you go there, only you have to do sync. That too, you can perform the synchronization with the special preamble and special PRATCH resources, which I got you from the other guy. So you can perform synchronization quickly. You can complete your random access procedure quickly, and your service will be immediately active in the cell, in the adjacent cell. If you take my help, if you ask me for everything, I will help you this way because I can talk to the other network node. But if you want to talk, you have to leave me and then you have to talk to the other guy. That will take time for you. So while you are still active on my cell, I will prepare everything for you in the background. And the moment I provide you all the details, you can leave my cell and you go to the adjacent cell, which is kind of quicker than you going there and getting the configuration. When if already configuration is pre available or already created for you to welcome you into the cell, so you can quickly move there. And your service, the ongoing service, which requires the resources, won't have too much impact. It will be quickly managed once you go with the already an existing configuration in the new cell. That's why network support is needed. So when you wanted to move when you are in connected state, you have to be dependent on the network. You have to request the network that I would like to move to the cell. But that is not needed in idle mode, as mobile is not utilizing any services. Even if you decide to use the next cell, in the next cell also it will be in idle mode. It will be sitting quiet, simply sleeping, doing nothing much other than listening to paging channel for incoming calls. So you kind of can do anything you want in idle mode. You don't need network support much. Of course, if you wanted to establish any call or something like that, you can request for a fresh radio connection. You can do that wherever in whichever cell you are present. But this year already call is going on, or some data is going on, some service is going on. You want to maintain that service. So you need network support. Of course, even when the mobile is in RRC connected state, it can be listening to, DCI, your PDCCH on with PRNTA basis to see if you have any short messages. Only for short messages, you will be looking in with PRNTA. Um, Incoming calls or incoming data can't not required to be reported in the connected state because it's already happening. In connected state, mobile is downloading the data, uploading the data. Network, if any new data is there, network can send it to you by you reserving the resources. That's it. Network doesn't require to tell you that you are getting incoming data because you are already getting the data. It can send it along with that. No need to tell the mobile that there is incoming data. But in your idle state, network need to tell you that there is something incoming for you. Incoming data is arriving or call is arriving. It will have to tell you that. But here it is not needed. And mobile would be listening to these control channels to find out which data is scheduled, nothing but PDCCH. It would be listening to this continuously. And also mobile need to perform providing the channel quality and feedback, nothing but CQI and your CSI information, channel state information to help the G-Node B to scheduling, antennas and things like that for you. Or your modulation and coding scheme decisions will be dependent on the CQI. So these are the activities that mobile is supposed to do when it is in RRC connected state. And mobile would be measuring the signal strength of the neighboring cells, just like idle mode. But in idle mode, by measuring the signal strength, mobile itself will decide which cell to use, whether to continue in the present cell or go to the next cell. But here, if the mobile is measuring the neighboring cells, it will have to report that situation, the reports it will have to send to the network. Why? It is the same point I have told here. You need the network help. You are reporting your signal strength through the network, explaining the network that a present cell is not good, adjacent cell is good. I would like to use adjacent cell services, not yours. Please move me there. You have to send a report to the network about it. But here you won't send any report. What do? You measure the signal strength. If the present cell is not good, adjacent cell is good, you select the adjacent cell and you read the system information in the adjacent cell and you start without having to inform the network about it. But here you have to report everything. Even before moving, you have to report. You can't move without network support in connected state. Of course, mobile equipment can acquire the system information even in connected state, especially when there is a report saying that system information has been modified. any of the system information details have been changed by using the short message indication, then mobile would download the corresponding system information from the system information blocks. Also, there is a possibility when the mobile is in RRC connected state, it can uh, MDT, it can perform MDT measurements and report. This MDT measurement typically stands for minimization of drive tests. In the old days, normally what used to happen is in 3G, 4G, etc., there will be a lot of drive test engineers in every company. Even Geo has the drive test engineers. So they'll have a van in that one huge UE equipment would be there. So they will take that UE equipment and they'll be traveling to each and every corner of the cell and they measure different things there. How much signal strength they are getting, what is the data rate, and so on and so forth. Like they'll be doing this drive testing to find out the network conditions. Based on it, they used to fine tune the network parameters accordingly. If they find out that in one particular direction, in one particular area, signal strength is not there, they will try to enhance the signal strength towards that particular direction. So like that. So all these things will be dependent on drive test results. But for drive testing, a separate team is required, and human beings who are like traveling throughout the network and carrying out these drive tests. But now they have put the drive testing possibility with the mobiles itself. Mobiles itself will be helping the network to come up with these drive test results instead of you sending a separate human being and a separate team to measure the things. So mobile equipment also can provide the help to the network. So that is related to it, which we don't require to study much. We'll ignore. But just to give you a pointer, I told you that. Okay, middle. In RRC connected, you are continuously transmitting the data either in the two direction or from direct, basically uplink or downlink. But what is this RRC inactive? When you are inactive, your data is kind of stopped. Normally, mobile equipment will first be put into DRX state at the MAC level. But if you are too long in short DRX or too long in long DRX, network after some time will find out that, hey, this guy is in long DRX state for too long. I don't think continuing this guy into RRC connected state is good. I think better move this guy into RRC inactive and ask the mobile equipment to measure the listen to PDCCH once in a very, very long while by configuring a DRX value. Discontinuous reception value. So in inactive state, if the mobile equipment is moved into inactive state, some of its functionality that it is having in RRC connected state will be discontinued. But this RRC inactive state is a state between connected and idle. You are neither idle nor connected, in the middle, where your context is stored, but it is called as UE inactive context. That means all the configuration details provided by the network are stored. If you wanted to come out of the inactive state and go into connected state, network doesn't need to provide you all that configuration once again, not needed. So that is the advantage between inactive and idle. If you go into idle, you have to get the complete configuration details from the network to move into connected state. But in inactive, you are making the mobile equipment to maintain this previously provided AS context information, which we call it as UE inactive AS context, and tell the mobile that, hey, any moment you wanted to come out of the inactive to connected, you can use the same configuration that I have already provided you. You're keeping it there. But again, when the mobile is in RRC inactive, it is not using any services, not sending much of the data or receiving the data. Again, mobile can go back into UE controlled mobility situation. It doesn't require network's help to move from one cell to the other cell. But when the mobile is moving, If there are something called as RAN-based notification areas configured in this inactive state, some number of cells are grouped into something called as a notification area. If mobile equipment crosses that cells and go into any other cell which doesn't belong to the previous notification area, then mobile have to perform notification area update. It'll have to perform. Tell the network that, hey, I was under the notification area number 5. Now I am moving into notification area number 6. I'm reporting you. So mobile, how does mobile detect which notification area it is present in? That information is available in reactive. It can move from one cell to the other cell, and every time it goes to a new cell, it definitely reads the system information. While reading it, mobile finds out when it finds out that this notification area value has been changed, modified, previous notification area number has been modified or changed. So immediately mobile need to go and communicate with the network and report that my notification area has been modified. So mobile normally would be listening to paging channel to find out if there is any system information related modifications are occurring, or it will be listening to paging channel with either 5G STMC or full IRNTI. What is this full IRNTI? IRNTI typically stands for inactive RNTI. So at the time when the mobile is moving into RRC inactive state, mobile would be allocated with a IRNTI. Stands for inactive RNTI. If network is sending a paging message to you on your IRNTI, indirectly network is asking you that, hey, it is the time for you to move out of the inactive state and come into the RRC connected state once again. Or I'm telling you that you need to come to the connected state. By using this IRNTI, the report would be sent on PDSCH channel. The corresponding paging message will arrive. So either the paging message can be related to the incoming call or data, or it is the network asking you to move into the connected state by sending a message by using full IRNTI. So mobile's activities are almost same, like idle mode. It will be performing measurements and selecting the cell on its own, and it can acquire system information either by requesting for it or whatever is happening just like that, or continuously if the system information is arriving, you download it. And of course mobile can log the measurements and in the idle or inactive state. Once mobile comes into the active state, it can send these reports to the network, idle mode or inactive measurements, if the network has asked you to measure those things. So the only difference between idle and inactive state is, in idle, mobile equipment don't have any AS context. It is not available. So it need to request for a radio connection, and it need to request for a dedicated configuration from the G node B. But in active state, you have that AS context available. So whenever you would like to move to RRC connected, the transition will be quick, immediate. It won't take much time. You are only basically wasting mobile equipment's memory to store this context information. Other than that, there is not much of a difference between idle and inactive states. They're almost similar, except having the mobile equipment maintain that AS context. Nothing but RRC configuration details provided during RRC connection. So from RRC connection, mobile equipment can go into RRC inactive state, or it can go into RRC idle if you release the connection completely. But if you suspend the connection, you will go into inactive state. So this is called as a suspend. This is basically called as a release. Which is shown in this particular picture here. So you can be in NR idle. When you establish a connection, you move from idle to connected. Or when you release the connection, you come back from connected to idle mode. Here you have the context available, which is called as the active context, active AS context, which you are using right now.
But here there is no context available once you release the RRC connection. But other than that, you have the middle part. From RRC connected, you release the RRC connection with the suspend. Meaning is it is not considered as a complete release. It is considered as the middle part where you go into inactive state, where the context is maintained, but the context or the configuration details are considered as inactive context, not active context. You are not using it, but you are just storing the details. That's all, like how RLC should work, how PDCP should work, how logical channel configuration should work, MAC layer configuration, what is it, physical layer configuration, etc. You're storing all the configuration details, but uh, you are not using it right now. But from here, you can resume this connection back into connected, move into connected state if you resume that. But from here, again, if you release it, you go into idle state without continuing back to the RRC connected state. So three states and transitions. Remember here, one important point. These boxes are called as states. If you wanted to move the mobile equipment from one state to the other state, some procedures will have to take place. These are called as procedures that are taking place between the mobile equipment and GNodeB. That means to move a mobile from idle to connected, definitely mobile equipment need to communicate with the GNodeB. Ask GNodeB that, hey, I want a radio connection. Please give me radio connection. If GNodeB accepts it, it will send you its acceptance. Then mobile equipment is said to be moved into RRC connected state. So here you are in idle state. After you requesting the radio connection and when it is accepted by the network, you are in connected state. So this particular procedure that is going on in the middle is a RRC procedure. So you require RRC procedures to change these state changes or to make these state changes from moving from one state to the other state. So for every state change, mobile equipment and GNodeB definitely will interact with each other. Mobile cannot change the states on its own. Our network won't change the mobile equipment states on its side and won't report it to the mobile. That doesn't work out that way. It must report it to the mobile. Even if it decides to change the state for the mobile, it will have to tell the mobile about it. Hey, now you are no more in active connected state. Now you are in inactive state. I'm moving you into inactive because you are too long. You are not doing anything. No data transfer you are performing. Okay, now this is not the end of it. This is when the mobile equipment is continuing in the NR network, 5G network. But let us assume, so this is a big area where the operator network is there. Like for example, if you take Reliance Jio right now, this is Reliance Jio 4G network. But only in some spots, Jio has started with 5G network implementation, where they see that there are potential customers are there who are using 5G services. They started bringing up some cells there, 5G cells. But what if subscriber who is a 5G subscriber using a 5G device, when it is in this particular locality, definitely using 5G services, it will be utilizing 5G network. But what if started walking and coming to an area where there is no 5G cell available? So then what? Then you have to go for the backup option. When 5G is not available, you must be moving on to 4G network. Typically, every 5G mobile will have all the old protocol stacks are also present in it as a software. So a 5G mobile phone contains 5G protocol software plus 4G protocol software plus 3G protocol software, 2G protocol software, etc. All old protocol stacks are present in your mobile protocol software. So if mobile somehow after some time decided that, hey, none of the 5G cells are looking good for me, I think better move to the old cells, search for any 4G cells are available here. The moment mobile finds a 4G cell, it will have to deactivate 5G protocol stack and it will be activating 4G protocol stack. 4G software it will activate and it will start communicating with the 4G network elements. But into what state you go when you are going from 5G network to 4G network, into which state you can go now. In 4G also, you have these three states called as UTRA RRC connected. This is NR RRC connected. That means you connected to NR mobile, NR cell, you are in connected state in NR network. UTRA means 4G network. You are in RRC connected state with 4G. You are RRC idle in 4G. You are RRC inactive in 4G. But these arrows, etc., are telling you what are the different possibilities. For example, you are in the connected state in NR. Suddenly you found out that the present cell is not looking good, but adjacent cells also not looking good, NR cells. Only the cell that you are finding better is LTE cell. If you report that to the network, 5G network will coordinate with the 4G network and will hand over the mobile equipment from NR cell to UTRA cell. But once you moved into UTRA cell, you will continue to be in RRC connected state in UTRA, but not in this is not considered as RRC connected in NR. It is considered as RRC connected in UTRA. So your activity is going on in the 4G cell, not in the 5G cell. Of course, data rates, quality of service, everything will be little impacted, because whatever the data rate that you could get in 5G may not be getting it in 4G, but you're still surviving there. So these arrows are telling you like what are the different transactions that are possible, or transitions that are possible from these states to these states. For example, if mobile is in RRC inactive state in NR cell, but suddenly it found out that at the time it is measuring the cell signal strength, it found out present cell is not good anymore, but LTE cell is good. Then mobile cannot move into RRC inactive in LTE. That is not possible. You have to first come to RRC idle, and if required, you have to establish a connection and go into RRC connected. And from there, you have to come to RRC inactive. UTRA. So this transition is not allowed from moving from RRC inactive to UTRA RRC inactive. Idle to idle, it is allowed. Connected to connected is allowed, handover. But inactive to inactive is not allowed. So even during inactive, if you move into other cell, you will be moving into idle state. So your whatever the stored context you have, that is useless in the new cell. You have to ask for a fresh connection to move into the connected. And then again, if you become inactive, you will be going into inactive state there. It's like that. So the transition is a long path. If you are inactive, you go here, you get a connection, then go to inactive. That too, if you are not doing anything, or the same way. From here, you will go into RRC idle, get connected, and then come back to inactive. You can't straight away move from inactive to inactive. Okay. Now, the last part before we go to our procedures. Signaling radio bearers. We have totally 4 SRBs. SRB 0 before RRC connection on CCCH logical channel. SRB 1 and 2 after RRC connection on DCCH logical channel. We already learned that part. But why do we require 2 SRBs? SRB 1 can be used for sending RRC messages, and before the SRB2 established, even if you wanted to send a NAS message, you can pack the NAS message into RRC and send it on SRB1. But once the SRB2 is configured, for sending the NAS messages, you have to use SRB2 exclusively. Of course, NAS messages always must be sent by packing it into RRC message. But you have to use SRB2 once SRB2 is established. That is a rule. SRB2 will have lower priority when compared with SRB1. Reason is, your radio messages are considered as important when you compare with service messages. NAS is service messages, which are moving from mobile to AMF, requesting for some service. Hey, I want that service, this service, etc. You're begging something from the core network. But radio is more important. If you ignore radio messages and send service messages, you may be actually losing radio link because the preventive action is not taken on the network. As this is given more priority, service request message is given more priority. So that's why you should never give priority for service messages. Only if a radio connection is existing, you can maintain your service, not the other way around. What is the use if your radio connection is lost? What do you do with your service request? Even if the service is accepted, your connection is already lost. So that's why RRC messages must be given importance. So when both of them fight with each other to send their messages, SRB1 will be given priority over SRB2. Okay, there is a question from Srinivas. RRC inactive is introduced in 5G, not in 4G, then why you try inactive state? RRC inactive state is not there in 4G in the original releases. Release 9, release 10, 11, 12, we don't have RRC inactive state. But release 15, they have introduced RRC inactive state in LTE also. It's called as advanced LTE. Okay. SRB3 we decided to ignore because it is related to NRDCR dual cell scenarios. We are ignoring that. Now, how many types of RRC messages we'll have? Only RRC. Only RRC always must travel on SRB1. SRB2 cannot be used. But if you have RRC plus NAS, both are present together. So even these messages also must travel on SRB1. This is called as piggybacking NAS messages. NAS messages piggyback to RRC. Piggybacking is, for example, if you are carrying a child on back of your shoulders, it's called as piggybacking. So NAS messages are piggybacked just like a bag on top of RRC. Such messages also will travel on SRB1. But once SRB2 is established, NAS messages will be carried on SRB2. NAS messages would be packed into RRC skeleton messages. That means in RRC body, nothing would be there. One skeleton message would be there, RRC message. In that, you will pack the NAS message and then start sending it. But for the third type of messages, will travel on SRB2 always. So if I have to draw the mapping, this must be sent only on SRB2. These two things will go on SRB1. Of course, once SRB2 is established, you cannot use SRB1 for sending NAS messages. But there is one more rule. To create SRB2, a security context must be enabled. Nothing but your PDCP level security mechanism, the one that we have studied, ciphering and integrity protection. So that must be enabled. Only after that you can create SRB2 or DRBs. It is a mandatory rule in 4G as well as in 5G. AF security related. All right. So with that, we have completed these basic concepts. Now getting into the deeper concepts of 5G. But before we go there, there are a lot of times that we will see power related messages or power related parameters in RRC. To understand that, we have to understand how the power is represented in 4G or 5G or any of these radio technologies. Power typically represents signal power, how much signal strength you are getting. Normally, signal strength would be measured in watts. We have a wording called as decibel watts. Now, what is the difference between watt and a decibel watt? Decibel watt is a logarithmic representation of a watt. So, For example, if you have any power value, if you want to represent it in decibel watt, you have to do it like this. For example, you have 1000 watts power. You substitute the 1000 in the power position. So it is log the 1000 base 10. We have 10 as a multiplier here. 10 log um, this 1000 can be converted into 10 power 3. 3 comes out. Log 10 base 10 is 1. So when 3 comes out, 10 into 3 is 30 decibel watts. So 1000 watts of power is equal to 30 decibel watts. Typically, logarithmic values are used to represent higher scale values, like bigger scale values on a very small scale. Even large number of watt value also you can represent with very short number in this logarithmic representation, because it's a 10 power representation basically. Okay. If you take 0.0001 watt power, which is equal to 10 power minus 3 comes out. So you have minus 30 decibel watt, which is representing 0.001 watt, which is also nothing but 1 milliwatt. Because 1 milliwatt is equal to, one watt is equal to 1000 milliwatts. That way. So it is a division by 1000. So when you see any values in minus in decibel watts, or normally in any representation, you have to understand that that is a very, very minute value. It is in milliwatts basically. That is what you have to realize. Okay. But you never use decibel watts in our representation in 5GNR. In wattages, because we never use watts in our mobile phones. We'll always will be using milliwatts. So for that, the notation they brought out is dBm, decibel milliwatt, where power must be represented in the logarithmic term in milliwatts. For example, if you have to again convert 1000 watts power into milliwatts, decibel milliwatts, how the value would look like. So because we need to convert watts into milliwatts, 1000 into 1000 milliwatts. So you take that becomes 10 power 6, 6 comes out. 10 into 6, 60 dBm. So 60 dBm referring 1000 watts, or 30 dB watt, 30 dBW also is referring 1000 watts. So always the difference between decibel watt and decibel milliwatt is 30 units. Difference will be there, always the case. For example, even in this case, minus 30 decibel watt is to represent 1 milliwatt. But if you are representing 1 milliwatt in decibel milliwatt terminology, it is equal to 0 dBm. So that is also 0 to 30 also is 30 units of difference. So always you will have 30 units of difference there. But decibel milliwatt will have 30 units bigger number than decibel watt. Because that is in wattages, this is in milliwatts. So difference between watt and milliwatt is 10 power 3. So that is why the 30 is coming there as a differential factor. Okay, so whenever we transmit the power, we'll be transmitting the power in milliwatts, decibel milliwatts. dBm, this is called as absolute power representation. For example, we use these numbers a lot in our radio. For example, if you take a cell, typically in the middle of the cell, mobile equipment may be very near to the cell center. Mobile may be getting 0 dBm power here at this place. That is nothing but your 0 dBm is equal to 1 milliwatt of power you are getting here, because you are very near to the cell center. Maybe here you may be getting minus 30 dBm, which is 0.0001 milliwatt here in this particular location. Maybe here you may be getting minus 60 dBm, which is 10 to the power of minus 6 milliwatt. At the edge of the cell, you may be getting minus 90 milliwatt or minus 100 milliwatt power, which is 10 to the power of minus 10 milliwatt, which is very, very small. Actually, these are logarithmic values. The difference between them every 10 dBm, they will become 1 by 10th, as you can see. So this 0 dBm to minus 10 dBm, this is 1 milliwatt, this is 0.1 milliwatt. Next one is 0.01, is another 1 by 10th of this. 1 by 10th of that is 0.001. 1 by 10th of that is 10 to the power of minus 4. So every 10 dBm, your power will be reducing 10 times. So this minus 100 dBm typically will be considered as a good signal strength. If you are, especially when you are in the edge of the signal, edge of the cell, 100 dBm is kind of considered as good because it's started getting generated at the G node B, traveling and reaching. By the time it is reaching, you are definitely losing some power. You are not getting the signal strength as it is when it is transmitted. When this guy is transmitting, it definitely use will higher power. But by the time it travels to your place, it is getting decremented. So distance increases, your power decrease. Simple concept. Is this clear, everyone? Understood this? Any question in this part? We all got this? I'm moving. Okay. So there is one more factor in radio power level related thing called as decibel. Decibel is different. Decibel milliwatt is different. Decibel milliwatt is power representation in milliwatts. It is an absolute power value. But on the other hand, decibel is an relative power representation. It is basically comparison of two powers. For example, you can consider it is a comparison between transmission power and reception power. Let us suppose you are transmitting a power of 20 dBm, but on the receiving side, you are receiving 10 dBm. Like you wanted to see how much amount of power loss happened. 20 dBm is equal to 100 milliwatts. If you convert it into the milliwattage units, 10 dBm is equal to 10 milliwatts. So if you try to find out the dB 10 by 100, you get 0.1. Log 0.1 base 10 is minus 1. So you get minus 10 dB. So if you have to write the formula, so it is like this. You're transmitting 20 dBm. While traveling, the signal has already lost 10 dB power. And by the time it reaches the destination, it has only got 10 dBm power on the receiving antenna. Transmitting antenna, transmitting it with 20 dBm, which is 100 milliwatts. But receiving antenna is receiving with only 10 milliwatt. It is receiving. 10 dBm is 10 milliwatt. So, but your power loss is 10 dB. 10 dB is not a linear value. Please, it is not a linear scale, just like 1, 2, 3, 4. 10 dB is like telling you that there is a 10 level drop happened to your signal. 100 milliwatt became 10 milliwatt, which is 1 by 10th of the drop. It is not 10 units drop. 100 is not, if 100 is becoming 90, it is 10 units drop. But 100 is not becoming 90 here. 100 is becoming 10. So always 1 dB will tell you that it is, 1 dB is by 10th basically here. For example, if it would have become 90, we would get the value 1 dB. 1 by 10th, if it is. Similarly, this is positive values. But remember, we never use positive 20 dBm. 100 milliwatts we never use in our mobile phone while transmitting or receiving. This is very high values. We'll always use 0 and below most of the time. So we are transmitting minus 20 dBm, receiving minus, our second power is minus 18 dBm. Actually, there is a power gain happened here in this case between these two powers. Actually, minus 18 is bigger than minus 20. So minus 20 dBm, if you convert it into normal milliwatt, it is 0.01 milliwatt. Minus 18 dBm is 0.01849 milliwatt. Do the comparison, you get 2 dB. So there is a 2 dB power gain. So minus 20 dBm, 2 dB power gain, you have reached 18 dBm, or actually minus 18 dBm, minus missing, sorry. Or minus 18 dBm, from there if you lose minus 2 dB, you will get to minus 20 dBm. Both places minus is missing. Just imagine that that is there. Similarly, if you take minus 57 dBm transmitted, you have received minus 60 dBm, definitely power loss. This is not power gain situation, this is power loss. How much power loss? Minus 57 dBm is minus 0.0002 milliwatt. Minus 60 dBm is 0.0001 milliwatt. So you get 0.5, which is equal to log 0.5 is minus 0.3. You get minus 3 dB. So that means the power difference between them is 3 dB. So on the actual linear scale, the difference is directly obvious. So you should not write like this. Never. You never should write like this. 57 dBm plus 3 dBm is equal to 60 dBm. That is utter wrong. This is not true. Because 3 dBm is like 20, 30 times or 70, 80 times bigger than 57 dBm. Actually speaking. If you take it in minuses. So they are not linear, they are logarithmic values. That's why, how do you have to write the difference between 2 dBms is always in dB terms. You have to write. So dB is basically difference between two powers. dBm is the absolute value. And in our specifications, you will see both the things every single time. Some places, for some parameters, you will see the things in dBm. Some parameters, you will see dB. So when they are showing dBm in the specs, they are talking about the actual power value. When they are showing you anything related to dB, they are telling you what is the power difference between the previous operation and maybe next operation. How much power increment or decrement you have to do. They are talking about that. So two different things. If you take even a deeper look at it, so it is look like this. I'm writing down all the values from minus 10 dBm to minus 20 dBm. Minus 10 dBm is 0.1 milliwatt. Minus 11 dBm is 0.7943. Minus 12 is 0.630. Minus 13 is 0.501. Like this, there are up to 0.01 milliwatt here. As you can see, minus 10 dBm to minus 20 dBm, power loss by 10 units here. 10 times decrease, 10-fold decrease happened here now. Actually, one important thing about 3 dB. 3 dB is a very important factor in telecommunications. Every 3 dB, power either will be doubled or halved if you're talking about the opposite case. How is that? Just take a look at it. The difference between 10 dBm and 13 dBm is 3 dB. If you take the value, here we have the value 0.1, here we have the value 0.05, which is kind of half actually. So if you divide it, we'll get a value 2. Or if you take this first and this next and do it, you get a value 0.5 if you divide them. If you divide this by this, you get 2. If you divide this by this, you get 0.5. Now, if you go back to the previous slide, whenever our ratio is 0.5, we get a value minus 0.3. We get this value. Whenever the ratio of any two powers is 0.5, half of it, we get minus 0.3, which is equal to minus 3 dB. So that is nothing but every 3 dB, the power became half. As you can see, 1 became, 0.05, 0.1 became 0.05. If you take next another 3 dB, you go here, you can see that it is become 0.025. Again, it became half. And again, if you take another 3 dB, it will become again half. You see in 19, 0.25, it is 0.125. 0.0125 is half of 0.25. So every 3 dB, the power would be becoming exactly half of the previous power. So 3 dB power gain means your signal strength doubled. 3 dB power loss means your signal strength halved. So that's kind of a popular value that we use in radio communications because of these power representations in logarithmic format. Okay. So with that, we have completed all the basics that are needed to get and start digging deep into RRC. So we now start with RRC procedures. We take a break here as it is a logical point. We take a quick 10-minute break. 11:30 it is. 11:40 we meet back and we'll continue. Okay, so join back, guys.